Welcome. I'd like to talk to you about simplifying radicals containing variables. For example, let's look at the square root of x squared. We're going to assume that our variables only represent positive real numbers. And square root x squared is asking what times itself will give you x squared. Well, the answer is x. That would be since x times x will equal x squared. Let's look at the square root of x to the fourth power. What times itself is x to the fourth power? Well, the answer is x squared, since x squared times x squared is x to the fourth power. Look at another example, square root of x to the sixth power. What times itself will give you x to the sixth power? Well, the answer is x cubed. And that would be since x cubed times x cubed equals x to the sixth power. You may start noticing a pattern here establishing. If you look at the exponent in the radicand, and you look at the exponent on the answer, it's just half the exponent on the radicand. There's on the square root, there's an index that's understood to be a 2. You just take the index, divide it into the power in the radicand, and it'll give you the answer. So here, 2 will go into 6 3 times, or we're just taking, since it's square root, we're just taking half of the power. So if we have square root of x to the 18th power, that will equal half of 18, or 2 going 18 9 times. If we want to look at an example that has more than one variable, say x to the 10th power, y to the 14th power, and maybe a third variable, z to the 26th power. We want to simplify that. Well, index understood to be 2. We're going to take half of each of the exponents. 2 go into 10 5 times. 2 go into 14 7 times. 2 go into 26 13 times. I hope this helps.